So good afternoon, everyone, and welcome to the first webinar of NEUTRALPATH Community of Practice. I'm Stefania Mascolo from Eurocities, and I'm happy to be your moderator for today. So the objective of this webinar is to explore, well, first of all, to inaugurate the Community of Practice of NEUTRALPATH, and to focus on a session for best practices and strategies for sustainable energy with our speakers from the University of Dresden. And of course, also address the replication opportunities and challenges related to this presentation and best practices. So first of all, I would like to thank all of you for joining us today, and a special thank you to our speakers, Katja and John from the University of Dresden. Thank you so much for being here. So the agenda is pretty straightforward. I will first leave the floor to our speakers for the presentations. And during this time, I kindly ask you to mute yourself. And if you have any questions, please write them in the chat. We will come back to them later. After the presentation, we will open the floor to the audience, to all of you, for, of course, addressing your questions. In this occasion, I kindly ask you to, and I encourage you also to open your microphones and your cameras. Provide your questions to our speakers, but also please do share your thoughts and perspectives on the elements that you have detected during the presentation that could be replicable in your cities and in your context, no? Because we are trying to focus the session on what are the replication elements from Dresden to other contexts and other cities across Europe. So we will use the Q&A section also for this purpose. This is the agenda, pretty straightforward. And finally, before leaving the floor to our speakers, I would also like to introduce you to the Community of Practice of NEUTRALPATH. So just a second, I will share my screen very quickly. So for those of you who don't know NEUTRALPATH, because there are registered participants from our partners, project partners, but also from all across Europe, I would like to briefly introduce you to the project and to the Community of Practice. What is it, and also what this Community of Practice can do for you. So, and for your work, of course. So the Community of Practice starts in NEUTRALPATH. NEUTRALPATH is a European project funded under the Climate Neutral and Smart City mission. The project focuses on the design and implementation of positive and clean energy districts, contributing to the climate neutrality journey of our cities. The cities participating and the related partners are 5, Dresden, Zaragoza, Banta, Ghent, and Istanbul. So the Community of Practice starts within NEUTRALPATH and from the professionals and partners of NEUTRALPATH, but it is meant to be and to become a wide community of members that are focusing and working on not only positive energy district, but more widely on energy transition and climate action across sectors and across Europe. So our goal now is to provide to the members, to you, to professionals, especially from the industry, so technology providers, industry professionals, researchers, as today. So to basically a wide pool of professionals to provide you with a forum for exchange lessons learned, experiences, but also challenges and innovative solutions that can overall contribute to the replication efforts to support the energy transition and the climate action and climate goals of the European Union. This exclusive forum that we are providing is especially focused on 2 main instruments, let's say. As members of the Community of Practice, you will have exclusive access to the webinars, such as this one, but also to an online group that is available through the Net Zero Cities platform with more than 4,000 4,000 users across Europe. So you will have basically a wide access to other peers and other professionals that are working across different sectors on the same topic as yourself. And the possibility, of course, to connect, share your innovative solutions, but also challenges that can overall contribute to these common efforts and common goals that we have. So please do join the community if you're interested. We are putting the link to join and to become a member for having access to this group and also to the next webinars in the chat. And do join the community and also, of course, share it with your network. So now, without further ado, I leave the floor to our speakers. Professor John Grunwald and Katia Tribulowski from the University of Dresden. I'm sorry, John, if I didn't pronounce correctly your surname. My German is not so good. So thank you so much, and I leave the floor to you.
It was perfect.
Yeah. You have to give me the presentation, right? So I can share my screen.
Mm-hmm.
Please.
Stefania, thank you very much for this nice introduction. Pronunciation was perfect. American pronunciation. The German pronunciation is Grunewald. Yeah? But it's everything is okay. Yeah. The presentation is coming up.
No, Stefania, please give me the rights.
Right.
No.
Yes. Just a second. Okay, you should be now able to share.
Yes, 1 second.
So here we are. I think everybody can see the presentation now. Yes. Very welcome to the audience. I'm happy to welcome you here and to talk about a little bit about the details, what we do in the frame of the Neutral Path project. The title of this presentation is quite ambitious, Revolutionizing Urban Energy. So at least it talks about energy, urban energy, which is one of our most important topics today. And in the city of Dresden, which is one of these two lighthouse cities in the Neutral Path project, we have two positive and clean energy districts. And one of them is called Pillnitz-Hosterwitz. This maybe is also different to pronounce, but it's a Saxonian name of a village which is now part of the city of Dresden. It's a little bit outside of the city center. It's not directly the city center, and therefore we have different conditions in comparison to the other location. So as I said, we have two different locations. And let's go to the next slide. Before I come to the project itself, I would like to introduce our institute a little bit. So we are a middle-sized research institute at the University of Technology in Dresden. We belong to the Faculty of Architecture. And you see here our workers. We are about 20 to 25 people. We do a lot of research projects. And you see some German words below the faces, which is energy concepts, buildings and quarters, material development and monitoring, sustainable renovation of buildings, and then, of course, thermal comfort and acceptance by the users. These are just the words of our research projects and research topics. And next slide, please. We are involved in we are divided in different working groups or teams. The first team is software. That's software development, meaning that we develop our own simulation tools in the field of hydrothermal performance simulation of the building construction, but also in the field of building energy performance of buildings, and also in the field of developing energy supply concepts on the quarter and the city level. So we are also able to simulate networks, domestic heating networks, and the sources. We are more or less specialized on geothermal sources. Then, of course, you need the validation of software that's done in the laboratory. It's called a building physical laboratory. It's located in the laboratory center at our university. On the right-hand side is a small picture of our laboratory. Then we have a team, Wissenstransfer. It's knowledge transfer in English. We have many projects also together with practice people, with companies, and we like to sell our ideas to practice to make impact. And this is one of our most important activities at the institute as well. And then, of course, we belong to university. We teach students teaching in building physics, building climatology, in building services. This is what we do. And basically, the teaching is very much influenced by research. We try to improve our teaching step by step and by influence from research. And quite recently, we got a new working group. It's called Green Technologies in Construction Engineering. This is a working group which is, as I said, quite new. It's growing. We have some Chinese guests and Chinese participants in this group, and we will see. This might be the future of the institute, perhaps. So next slide, please. Well, this is what we have seen already. This is an example of our building simulation. You see here a building which is located in the city of Dresden. And here the thermal comfort, the indoor thermal comfort was one issue. They got big problems with overheating. At the same time, of course, the energy efficiency must be improved. And that's the reason why we got engaged to model the building coming from the architectural side by so-called building information modeling. We were able to take over the BIM model to our software by interface, and then you can simulate the building physics, the thermal comfort, the building energy performance. Also, soil physics is included, the ground heat exchangers, flat collectors, boreholes, and so on. And as I said already, domestic heating networks, which can connect our sources and consumers of energy. Next slide, please. Our software, we have different software tools under development, but the most impressive one and maybe the most important one right now is SimVicus. That's the tool that enables us to model buildings from scratch or to import buildings from CAD via BIM interfaces. So there are different ways of modeling buildings, and then to trigger the energy performance simulation and also the post-processing to evaluate these results after certain key performance criteria. One thing that we already discussed in the neutral project, the NEUTRALPATH project. On the right-hand side, you see some simulation kernels and tools. One is Delphin. This comes with own user interface. The Delphin is specialized on hydrothermal transport processes. Actually, this goes back to my own PhD. Hydrothermal transport in porous media was my research topic. And this has been applied to building constructions to avoid typical building physics problems like frost damage, like mold growth, and these things like condensation in the construction. If you insulate a building construction at the inside, then you have the dew point, the condensation point in the construction. This is a typical application example to avoid damage after renovation of buildings, especially historical buildings. And this Delphin comes with a powerful numerical kernel, therefore it's listed under kernels. But also TerraClass and Nandrat are kernels. Nandrat is the kernel of SimVicus. So as a multi-zone building energy solver, which includes this network simulation. And then we have a master sim that we can couple different simulators together. It's called co-simulation, this technology. And finally, the post-proc, which is specialized on evaluation of simulation results, because you got huge gigabytes of simulation results and you need to evaluate this somehow and come to conclusions, and the post-processing is the tool to do this. Here you see one of our projects, which was, the topic was our own campus of TU Dresden. In the upper picture, you see the whole campus. And you see the greenish buildings, they are modeled as well, but they just shade. So they just stand there, but they are not simulated. The brown buildings are modeled in very detail, so room by room, and each building wall construction is modeled, including everything that is going on inside, like user behavior, presence of users, light on, light off, all the heat sources, the ventilation. These things are modeled as well. And underneath, you see some of the building examples that has been created during the course of the project Camper. So next slide, please. And the top picture is one of the buildings of our campus. The bottom picture is the Hagia Sophia. I tried to model this myself. This was a challenge, of course, but this was my first modeling exercise. So now I come to some research projects in the field of geothermal energy supply, heating supply. And the projects run since 2016. So about 8 years ago, we started this topic. And the basic idea was to use the knowledge we have already in the simulators, hygrothermal simulation of transport processes, which is important in the building construction, to use this also for the ground, because the soil and the subsoil is an energy storage, and the moisture plays also a very important role, and therefore it was clear that we could apply our tools in this field as well, and started doing simulation of geothermal heat exchangers, and including thermal and moisture transport processes. Everything is, of course, a non-stationary transient simulation. So on hourly basis, we usually take the weather from our German weather service, apply this as a boundary condition, either to the soil or to the surface of the building, and then ask certain questions that can be answered by simulation. You see 3 projects called Erdice, means soil, ice. The basic idea behind is that we keep the subsoil very moist, maybe by application of a foil as a liquid water barrier. Then install the sensors. Maybe there's some picture later on, and then freeze it during winter time. And this releases additional energy, phase change energy. That means we get more heat in winter time. And then we have an ice block created in winter time. And then we take this ice block to the summertime and have free cooling for the buildings. And actually what is behind this, it's a transition of heating and cooling energy between wintertime, a shift between wintertime and summertime. And it's a seasonal storage. And therefore, this is called Erdeisspeicher, soil ice storage. And we have 3 projects in a row. The first has been finished already, is completed. The second is almost finished. And the third is running right now, which is focused on the monitoring of these systems. Fortunately, we have a municipal energy supplier in the north of Germany who implemented this or installed this, built it, and we have a research project where we do the monitoring and the comparison with our simulations. And then we have KNW Opt, one project which has a a large flat collector connected to a district of the city in Bad Nauheim. And then we have a project called multi-source, different heat sources connected in a cold temperature domestic heating network in the city of Bamberg. It's called Lagarde Campus in Bamberg. Now I would like to come to the city of Bad Nauheim. You see here in the upper left picture the location, the quarter, which is a newly erected development area of about 180 buildings with around 400 residential units for about 1,200 residents. 3 construction phases has been finished now, is in operation. The monitoring runs, and the heat source, you see the picture in the middle, is on the bottom, and this greenish field in the bottom, that's has the dimension of 90 times 120 meters. It's like a soccer field. It's the size of a soccer field. And we have 2 layers of flat collector installed there. And the connection between this flat collector and the buildings is done by a low temperature domestic heating network. And this one selects, it collects heat instead of losing heat. That means we gain heat during the operation of this system, and the collector and the network, they work together as one system. This is a very important outcome of this project, that we see that these systems benefit from each other, leading to the conclusion that the collector, you see here the installation of the collector, the size can be decreased. And this has very important consequences for dimensioning of the sizes of such collector systems. Once you know that the connection between the collector and the buildings, the network pipes collect heat as well. Most of the time, the heat is well, the heat collected in the pipes regenerates the collector most of the time in springtime, because the height or the distance to the surface of the earth is smaller in case of the network than the collector. The collector is deeper. That means the collector stays longer time cold, and the heat wave in springtime that comes from the sun reaches the pipes first. So the temperature rises in the pipes first, meaning that the regeneration is triggered by the pipes in the first place. So here you see our Simvicus simulation of all the buildings. This was done at a certain time point before everything was built. So it was a completely empty building site once we modeled these buildings. And of course, there was no architecture. There was almost no information available except energy standards and square meters and numbers of how many buildings. And just by using this information, we were able to create this simulation setup of this quarter by a technology that's called generic building models. These are generically generated building models which follow a certain layout assumption. And then the time to create such a building model, which is fully parameterized and fully detailed, it's about 1 minute. In 1-2 minutes, a building is built, and just building by building, you finish the building site, and then you can start the simulation. The outcome of the simulation are the load curves, so how much energy or how much heating energy, how much cooling energy is needed at which time, which hour during a year. And then this is the basis to lay out the network and the collector. And then, of course, you can also simulate the collector in the network. You see on the right-hand side the pipes, supply and return, and the interaction of the pipes with the surrounding soil. As I said, we collect energy instead of losing it. And therefore, it's important to quantify this. So we need to have a model which is able to capture these physical processes. So the heat transfer inside the soil and the heat exchange between the soil and the pipes. And also the temperature in the pipes. There's a length of about 6 kilometers in total of this heating network. And of course, in each meter, you have a different temperature and therefore also a different exchange of heat with the surrounding. And on the left-hand side, you see the collector simulation. You clearly see these blue stripes, which is cold temperature. And that's the action of the collector layers in wintertime when they get the heat out from the soil. And what we need to apply here is, this is of course a problem that cannot be solved by one simulation kernel alone. We need to couple 2 or 3 together. So one, for instance, the Delphin simulation kernel for capturing the physical processes in the soil, and then the NANDRAT kernel that can calculate the thermal hydraulic network. So what is going in the pipes, and this is coupled by an interface which follows a certain standard. It's a functional mock interface, functional mock-up interface. This is a European standard on coupling of different simulators. So basically, our conclusions we can draw from these research projects for now is that we get some advantages when we have cold local heating networks, domestic heating networks, and at the same time, shallow or near surface geothermal energy sources. As I said, we can generate additional gains, additional heat gains by using the network with no insulation, uninsulated pipes, of course. And we can amplify this seasonal storage effect. So shift the heat from summertime to wintertime and the cold from wintertime to summertime. And of course, the network makes contributions to the better regeneration of the soil. And also, if the buildings come into play and we produce our own electricity on the roof of the building and use the buildings as a heat storage, then we got additional degrees of freedom, more freedom to use our, to increase the share or the amount of electricity we use ourselves. Well, the collector reaches the coldest temperature in February. That means we have also a time shift in comparison to heat pumps that are connected to air. The coldest day in the year, of course, is the worst day when you have an air heat pump. But if you have the subsoil and the soil as a heat source, then this is not the case. Then we have still higher temperatures in the soil than in the air. And therefore, it makes sense to have a technology in place that can select between the soil and the air, and the heat pump can use actually both sources, air and soil, and take the best one all the time. A few words about ice. So I started with the earth ice project. You see here the simulation of this earth ice storage. On the left-hand side, there is the temperature and the ice content. So this is an outcome of Delphin simulation. We can quantify how much ice is produced at which time, how much energy is released by the creation of ice. and what is the benefit of this. And you see the benefit. This is the graphic, this picture on the right hand side, and the uppermost picture. You see the temperatures in certain depth in this ice storage. The red curve, of course, is the top sensor location, has the highest fluctuations, and you go step by step down in the soil. You see the amplitude shrinks, and if you go maybe to 1.0 years in this time scale, you see that it doesn't drop below 0 degree. It stays constant at 0 degree. That means there's no colder temperature in our ice storage than 0 degree. That means during this time, when we have this flat curve, during this time, we have the freezing process, and the freezing process prevents the temperature dropping below 0 degree. So as long as we have freezing, as long we have 0 degrees, then maybe if everything is frozen, maybe have a complete solid frozen body, then of course there will be a drop below 0 temperature. But this has not been reached in this operation of the system. So we survive somehow with using the energy from the ice. What we need basically to generate knowledge about all these systems is simulation. And our wish is our vision to transfer this knowledge to practice, meaning that of course, we can do also some planning, we can help, but we are a small institute, and many more people engineers should use these technologies. But it's quite difficult in the moment, especially in Germany, because we are still in the fossil age, and many engineers are still following fossil business models. And it takes some time to convince people and to change people. And therefore, my argumentation is that traditional business models, which are built on the availability of cheap fossil fuels, should be overcome, because the result of such business models is oversized systems, which has been investigated by a paper statistically. And it has been proven that many of the heating systems, fossil heating systems, are oversized, which is impossible or not reasonable in case of regenerative or renewable sources. And then to make it better, you need a better design. You need more precise prediction of energy demands. And that's the reason why the simulation comes into play, which allows you to model much more precisely than our current standards do. It means fossil planning processes or approaches are not longer effective. We should come to renewable ones. So develop and establish new planning methods. So I belong to a faculty of architecture. I try to convince architects to start with resource analysis before thinking about building shapes and building designs. So the resource analysis should be the first point. How much energy is available on the place? How big can the building be then? And how efficient has the building to be? These are questions we need to ask in future. So a precise design on edge due to the limited availability of renewable resources. And of course, CO2 must be balanced. At the same time, euros must be balanced. So we need to look at CO2 avoidance cost, and the most efficient technologies must win, I would say. And at the same time, we should also, can you go one slide back, please? We need to go to real physics, because simulation is based on real physics. Digital twins are based on real physics. And we need to master a large amount of data. So all this requires more data. It needs validation, and validation is monitoring and comparing monitoring. We come to this. Yeah, now Katja.
Yeah, Katja,
thank you,
please
Professor Grunewald.
It's your turn.
Let's take a closer look what we can achieve with these new planning methods, as Professor Grunewald described, with regard, of course, to transform fossil energy supply in Dresden towards renewables. We're going to check the second demonstration site of the EO's NEUTRALPATH project, the quarter Pillnitz-Hostowitz, owned by WID. That's a company which is owned by the city in order to provide citizens with affordable living spaces. On the map, we can see the city of Dresden, the Elbe River dividing the city, and the site A of the project is Jessener Straße. It's a more central living block, and site B is a bit more in the suburban area outside of the district heating network of Dresden. And as we can see from the green character of the site and the more spacious way of building here, we have better circumstances for local renewable energy supply, and also, well, the challenges that come with being in the city periphery. So the current status on the site, as planned and as the development will be, is that we have 5 old buildings from the 50s. They have to be refurbished. And we have another 3 buildings here in the top. They were also from the 50s, but they already have been refurbished during the time, and they shall also be possible to include in the local energy supply concept. And for the development, there will be between 4 and 6 new buildings created in the coming years due to the increased need of affordable living space in Dresden. Social housing for the city is very important and needs to be secured and planned for that reasons. So according to the professors and therefore the Institute's philosophies, we used digital twins and simulation technology for the design of the energy supply concept here. We started off with, of course, data acquisition. WID, the owner of the properties, provided us with a structural condition survey, plans of the houses, as well as operating cost statements. With that, we had quite some work in order to validate the initial data on heating supply energy of the previous years. Not only had significant gaps, but was also hard to validate against the digital twins, because it seemed like people living there rather put on pullovers in order to stay warm than actually turn on the heaters. They barely opened the windows for ventilation, or at least much less than the usual. And as I said, barely used the heaters and accepting the low comfort though. Anyway, after some thorough research and even laboratory tests on the bricks from the site, the data was properly processed and ready to use for validating and calibrating the simulation model, aka the digital twin of the site. This was the foundation for designing the energy concept. On the right hand, you can see the simulation models in the software we used. Simbicus, as the professor already presented. The houses here are shown actually in construction mode. Every construction has a different color. As you can see, the yellow houses with the red roofs are the ones to be refurbished. The green walls with the blue roofs are the new houses, and the blue houses with the orange roofs are the already refurbished ones. On the picture above, you can already see the special system we intend to use for the refurbishment for the old facades. The idea is for renewable energy and heat pump technology, we need low temperature systems. So we need surface heating systems for good efficiencies on the heat pumps. A big problem for refurbishments, therefore, is that tenants need to be moved around. Since it's quite an effort of work, organization, and money-wise, the team decided to take actually a different approach. We apply the surface heating system from the outside. So an exterior insulation heating cooling system, or as we say in Germany, Dämmheizkühlsystem, or like the name is active DHKS. The idea is to have even lower supply temperatures, therefore better efficiency, or mostly significantly oversized, with like causes of financial disadvantages for renewable systems. Therefore, we use the digital twin and simulation technology to provide us with a more realistic energy demand databases for heating, cooling, and of course electricity. An hourly curve, as you can see on the right-hand side, over like the whole year for all buildings was created as basis for a variance study for dimensioning like the components and making a well-founded selection for the final energy solution. So the variance study included 3 options of bricks, like brick materials, in order to determine the actual material on site. Since due to the thermal activation of the bricks, this is a very, very important parameter to determine. To begin with, the supply temperature of the exterior system was set to constantly 20 degrees, and there was no control according to, for example, photovoltaics surpluses. The interior radiators are always controlled by the room thermostat, and the supply temperature depends on the outside temperature. Here we have, for example, up to 40 degrees supply temperature. In further variance, in order to optimize the heat curve, there was a control that we have, like when we have surpluses, the supply temperature of the exterior system is increased from 20 degrees to 28 degrees in order to store extra energy in the outside wall, kind of like a big buffer storage. Another variant was examined where the exterior supply temperature was altered between 18 degrees and 22 degrees when there are photovoltaic surpluses. Also, one variant was examined where the exterior system only runs on constantly 20 degrees when there are photovoltaic surpluses in order to optimize the heating load. The optimized control of the 2 systems in combination with each other and outside conditions is yet in further research, and there hasn't been found a final setting yet, since like the control is still a big research issue. The problem is the inertia of the system in comparison to fast changing weather conditions, especially in spring and autumn. For further optimization, we think of maybe involving predictive weather sensors as well as to optimize the use of the thermal mass storage. So these are very detailed problems for the system control, but anyways, the components could already be chosen for the supply concept. The old buildings are going to be refurbished with the active DHKS, like I said before, and the existing radiators are reused on low temperatures. Since no boreholes are possible in the area due to it being a water protection area, geothermal flat collectors were chosen, as you saw in the pictures of Professor Grunewald before. The heat pump was chosen already at 200 kilowatts with the potential, of course, of making it smaller. We just wanted to be on the safe side for now, cost-wise. The collector is about 2,000 square meters of size, double layer in about 1.50 meter to 2.50 meter depth in the ground. And there's a central buffer storage of 15 cubic meters. The domestic hot water is provided with instantaneous water heaters, which you may think this is energetically not very efficient. Sorry, but we had various calculation studies that this is actually the most economic way to provide the hot water in this case. In the new building, the domestic hot water is going to be preheated also from the geothermal source, but for existing buildings, this was not economically possible to achieve. So here we can see components in all houses. Every rectangle stands for one of the houses, as you can see. The old houses get the active DHKS, the exterior surface heating, and insulation on top, of course. There's going to be a power center separate little building in the middle for all the components such as the heat pump and the buffer storage. The network is a warm network between 15 and 40 degrees of temperature, and the heat pump actually has two sources in combination, like geothermal and the air system. Since the air system operates in periods like spring and autumn, more efficient than the soil source, because the soil temperatures mostly are like colder on days like today, for example. So this helped to reduce the geothermal collector for approximately 20%. Here we can see actually a single house, photovoltaics on the roofs, and we see that in the whole network there's like a two conductor like system, but actually in the houses we have two different supply temperatures. Like the radiators have a higher temperature than the active DHKS, and we provide that like that we mix colder water actually with the supply temperature from the network to actually optimize the temperature of the active DHKS. We also did studies with like a four pipe system, but the costs for the four pipe system were actually higher than this one. So this was the like best solution for the quarter, since it needs to be like affordable for the social housing. So here we can see like a summary of the approach of the business model. Since the owner, like the VED, the owner of the property, cannot provide the energy system, therefore the regional energy supplier Sachsen Energie invests in the components and sells the energy to VED and the tenants, of course. The business models for that new kind of supply concept, local and renewable, are now in discussion between the partners. And although the concept is optimized regarding like own consumption and self-supply, the site is not self-sufficient or autarkic. Mostly or like only in the winter time, we still need a little bit of electricity from the network in order to insufficient solar production on the site. So it means the sun is not that generous with us here in the winter, unfortunately. Yeah, but anyway, we cannot change that. So the importance of the system, or what the system actually improves, is the thermal comfort, which is like a basic requirement. We have to include renewable energies and therefore need like this surface heating and cooling systems. And we also address hydrothermal issues, such as, for example, algae growth on flats, which is also like always when you put like ETICs on walls. So the activation of the thermal mass storage actually has various advantages, also like peak shaving for electricity peaks on the network or load shifting. So to come to a conclusion, like how's the project like moving forward? The next steps are going to be the call for tenders for planning and implementation of the services, the development actually of the business model for decentralized energy supply with Sachsen Energie and other partners, the construction and implementation phase, of course. After that, we're going to do brief monitoring and, of course, comprehensive documentation of the project results. Also, of course, regarding scalability and dissemination. So in other like quarters, the same like system could be applied in order to make the transformation towards renewable energies. So to close with a quote from a famous politician: during our work on the project, we can identify with that statement. Often the problem was not that it's not technically possible, but rather that it's legally possible according to German standards, which are still, like Professor Grunewald said, from the fossil ages. In the end, I'd like to introduce you to the project team. Of course, head of the institute, as you saw today, Professor Grunewald, our project leader, Dirk Weiss, and myself, Katja Tribudowski, research assistant. And now we thank you for your attendance and are open for questions and looking forward for the discussion.
Thank you so much, Katja. Thank you, Professor. I think it was an extremely interesting and also a forward-looking presentation. So just what we were looking for. So in the meantime, we already have received some questions in the chat. So I would like to leave the floor, first of all, to Julia. If you would like to switch on your camera and pose your questions.
I believe it's me. Thank
you,
Stephanie. Yes, I was checking the district modeling simulator, SimVicus, I believe. So many congrats. It seems like a very useful tool to simulate at the district level. So congrats on that. And now I was wondering that because my experience with simulations models is that usually if they're not properly calibrated, we have very distinct values when it comes to simulation values and real values on this, especially if we're analyzing at an yearly basis. So my question would be, were these simulations calibrated? And with this new tool, how can we calibrate these models in order to reduce the error between simulation and real data?
Thank you for this question. Yeah, Katja, do you want to go ahead?
Yeah. Yes. The calibration actually was a bigger process with this project because, as I said, the data acquisition, like the operating cost statements from the owner of the property, had significant gaps in it. So it was not like the perfect basis to calibrate the simulation model. And also we didn't have, because the buildings were from the 50s, the people back then, they were building a house with what they had. So even if the plan said this brickstone was used, not actually this brickstone was used. So actually we went to the site and took some samples from the bricks because this was like a real issue. The bricks used actually have a very higher heat capacity than we estimated actually for the 50s. So they were quite good. And that was the first thing we had to calibrate. And the other point was really to calibrate the users, because when you see the operating cost statements from the old buildings, sometimes they had the same costs like the exact same building next to it, which was already refurbished. And there, like, as a physicist, you say like, no, this cannot be it. Like, this cannot be real. And the actual reason behind that, we researched actually quite a lot. The people were really not turning on the heaters, but we had no temperature sensors there. So it took us quite some time to figure out that the people were actually like coping with the cold temperatures there rather than turning on the heaters, because there's social housing and the people were just afraid actually to have higher costs. Yeah, but the simulation model is only as good as the foundation and basis parameters you parameterize it with. So this is like a big point, that you have to validate yourself what you put in as parameters, and when you see like and compare it to like actual cost statements for the operation costs, you have to validate it and check for the reasons why it differs. And there's always it always differs. That's why we actually validate it with like the real costs there.
Short remark from my side. Of course, it depends on the quality of your data. And here in Pillnitz-Hosterwitz in the neutral path, there was almost no monitoring data except of the energy bills. And we had some difficulties to match this. And the explanation was clear. On the other hand, in the research projects, especially in KNW Opt, I have introduced, we have a scientific monitoring. And this scientific monitoring is very detailed. It's also on sub-hourly basis. And there are hundreds of sensors and gigabytes of data. And this is a full position alone that takes to evaluate all this data. So fortunately, we have some resources to do this. And then you come to much better results. In the moment, we have 2 PhDs. One is almost finished. The other one will be finished by end of this year, which did this validation and calibration of the SimVicus tool. And this was very successful. So we got very good results on calibration and validation. We even could explain effects that could not be explained without simulation. Just to give you an example, we have moisture sensors in the soil measuring liquid water. In winter time, the soil dried out dramatically. So there was almost no water in the soil anymore. physically impossible. And people thought sensors are broken. Yeah? And then we did a simulation, we got the same result. And then we thought about it. It was a physical effect because ice is not a liquid water. It's not measured by sensors, and it's not. It's a separate physical quantity in our simulation. Of course, we have this ice content, but the liquid water content also decreased, and this was the reason why we could explain this. But this is a completely different level. This is research, and what we talk here in NeutralPath, we don't have this scientific monitoring yet. Of course, we have to start with some energy numbers we got from the energy provider and from people themselves.
Thank you. Thank you for your answers, and good luck on your project. Seems like a very hardworking model so far, and I hope you get to your goals in the end. Yeah.
Thank you.
And just one more thing, which I think it's important also, it's that in Portugal we also got the same results with social housing when it comes to the energy consumption. And our conclusion was that refurbishment of social housing, it's not about reducing electricity costs. It's about increasing indoor comfort or air quality for the residents, because they will not spend that energy. Whether their house is 16 degrees or 20 degrees, they will not turn on the climate devices that they have, because they don't want to spend that money on electricity. So it's more about increasing comfort. In our case, it was more about increasing comfort for residents than decreasing the energy costs. So this increases the calibration problems that we had, because we didn't understand why with some new materials we were getting the same bills for one house and the other one. Yeah. So thank you.
Thank you.
Thank you, Julia. So the next question in the chat was from Arnold. Arnold, would you like to switch on your camera and pose your question?
Hello, hi, John, hi, Katja.
Hello.
Thank you for your presentation. I hope you hear me all right.
I see you.
I had a question in relation to the fact that the number of dwellings that will be connected to the district heating network is in fact unknown during the design stage. I think this mainly relates to Bad Neuheim. There, John, in the slide, it said that there is no compulsory connection to the district heating network. So how do you deal with this in sizing the source and the network? Isn't there a risk that the network will be oversized if it is not sold correctly?
Yes. Very good question. Thank you for this, because this was a real problem. We, of course, assumed that I think between 80 and 90% will be connected to the network. And our simulation were based on this assumption. And then, of course, the outcome was the sizing and dimensioning of the network, and the source was based on these numbers. On the other hand, as I said, a simulation goes to the edge. So it's always, let's say, a very precise simulation or a very precise calculation, as precise as possible, of course. And there was no room, so we didn't do 50 or 100% more than needed, of course. So it was very accurately calculated. And therefore, there is no reserve. And we were a little bit afraid if 100% will go this way, then it could be too small. But at the end, it was a matter of making it attractive by prices. And the energy supplier, the municipal energy supplier in Bad Nauheim, they have a certain strategy. They say, okay, our prices are below the fossil prices, a little bit below, not too much below. So this makes the approach attractive. At the same time, they communicated this is renewable energy. Of course, you can use your own solution, but you will get a renewable solution if you connect. And this motivated many people, and we saw that the rate of connecting people was pretty much the same we assumed. So fortunately, it worked. But you have, of course, you have the possibility to lower the prices to make it more attractive, or to raise the prices if you have enough already. This is then maybe a matter of the Stadtwerke, the energy supplier.
Yeah, and the solution is future-proof in the sense that you already offer renewable energy instead of fossils.
Yeah. But what is the alternative? The heat, air heat pump, maybe. Maybe some of them rely on air heat pump or different technologies, but very few of them.
Actually, for the NEUTRALPATH site in Pillnitz-Osterwitz, we are very fortunate with the owner of the property is like not the tenant, like in Bad Nauheim. The owner can decide for the whole quarter the energy supply. So there's not the question, is every house taking or being part of the network? Every house is going to be connected to the network. So this is very fortunate in Pillnitz-Osterwitz that we have this situation. So we don't have a risk actually how many houses are going to be connected. The only question is during the planning process, because the VID, the owner, doesn't know how many new houses are going to be built. It's approximately between 4 and 6. And this is also like kind of like we can do all 6 because the new houses don't have such a big demand because it's new build, so not such a high demand. So this is the only challenge we will have, but this is going to be cleared out during the planning process actually.
Yeah, thank you.
If you want to go ahead.
Yes, thank you. I just wanted to underline what was said, what was already said. When we started the project and when we had our consortium, we always said that we want to guarantee cost neutrality for all the tenants in all quarters, in test quarter A and in test quarter B. So it's always our aim to have the same cost or low for the tenants than before. Yes, and this should be our aim in the future. But anyhow, I would like to say that the concept that was shown is a very good opportunity to supply or to develop new decentralized areas in our city. So to develop suburban neighborhoods that are not yet connected to our central district heating grid. So yeah, it on the one hand side, it's a good opportunity for us to have more customers, but on the other side, it offers or we meet customer needs or the customers' expectations to have or to take part in the energy transition and to be supplied by renewable energies. So we have both sides, and that's why this is what the project is about. So we transfer the knowledge into practice, and we transfer the research that was done by the technical university and spread it and bring it into the mass and make it usable in a large scale. Yeah, and therefore it's good for us as the local energy supplier. We support those investigations. We support the researches of Professor Grunewald, Professor Felsmann, and have this in our, we're grateful to have those expertises in our projects.
This was Georg Hamann from Sachsen Energie, our energy provider. By the way, you don't make much money or much profit if you raise the prices in 1 quarter, of course. This is almost nothing. But if you lower the prices, make it attractive, then it can be multiplied and more people will believe in it. And then maybe you make more money. And therefore, my strategy would be rather lower the prices than raise them And I think it's our own, our all together, our responsibility to create conditions that those solutions can be multiplied in the city, because this will serve the climate neutrality of the Dresden city.
Thank you. We also had another question in the chat from Rosalia. Would you like to switch on your camera? Yeah.
Yeah. Hi, everyone. Thank you for the presentation, Katia and John. I believe it's a really interesting project, the ones that you presented and the implementation in Neutral Path that you are going to do. I was wondering that in the projects that you have presented, most of them are in relation to new constructing areas or places that have large empty space to incorporate the low temperature heating network. If you have considered how this could be implemented for areas which don't have this large amount of empty land, or the areas that are empty are too far from the houses that they are supposed to connect. Thank you.
Yeah,
maybe
for
I can
us, like,
say,
sorry.
yeah, I can say some word to this, and then Katja. Well, in Bad Nauheim, we see that we can use energy sources or areas like this soccer field collector, which are a little bit far away from the buildings. In this case, we have a distance of 2 kilometers. It could be even more. And the benefit is that our pipes collect heat as well. The only thing that increases is the electricity demand of the pumps. If you have a bigger pipe, you have bigger pumps. And but the gain of energy is bigger than the loss of energy. That means we collect more energy by a bigger domestic heating network. So the conclusion is that we can use areas which are a little bit abroad of our buildings. So if you have a densely populated city center, then of course the demand is much higher than the availability of resources. And then of course we need to rely on networks. And on the other hand, I believe we, even in densely populated areas, did not use all the possibilities up to now. We still have some possibilities. Maybe underneath of streets. Maybe streets can used as heat sources. Drilling boreholes underneath of streets could be one option. The drilling technology has made a lot of advances in the past or in the last time, and therefore we just need to continue to research and development in this field, and maybe also to overcome some hurdles. In the moment, there are a lot of there's a lot of concern about the groundwater quality, and maybe there are some conflicts with the protection of the groundwater and the harvesting of heating energy. But on the other hand, what is the better solution to build the next gas pipeline between continents, or to import the energy from different continents like Africa? This requires infrastructure which has a much bigger impact than the little impact we should allow in our areas.
Okay. Yeah, thank
Katja?
you.
Yeah,
yeah.
of course, like the professor already said, like it's his philosophy actually to first get the low-hanging fruits. So for us, I mean, Plönitz-Hostowitz is a suburban area which gives like space potentials, of course. And the thinking here is to transform the city from the outside to the center, because in the suburbs we have the spaces and actually to like get the energy, and we just yeah, go closer and closer to the center, as site A is closer to the center and is making like similar approaches. So yeah, the challenge is actually from the outside to the inside, just step by step. I mean, you cannot transform everything one by like at once, and actually the approach we take is not only for flat geothermal collectors, as the professor already said. We can also connect boreholes, air, heat pumps. So it's always like a connection of various systems in order to optimize like what you can actually locally get energy-wise to support or to supply your buildings. It's like from quarter to quarter, it's different, and you have to plan it and see it as such different case every time.
One small additional remark. I read some numbers about it, Dresden, and to my knowledge, we have 1/3, 35% of buildings are connected to the domestic heating network. At least this was the case a couple of years ago. And 66% is not connected, is just supplied by a gas network. So they have the heating system down there in the basement, just a gas boiler. So that means 66% at least is a potential of being transformed to renewable energy. But I believe we need also in these areas, we need networks anyway. So network is very important, domestic heating networks, but not old networks like we used in the past. I think we call it the 4th or 5th generation of domestic heating networks with low temperatures. This should be the future in these external areas. And then the energy can maybe flow from outside to the inside of the city, not vice versa, which is the case now. We have a power plant in the middle, and the energy is flowing from the middle to the outside. So we should reverse this energy flow.
Okay, thank you. Yeah, I think that's an interesting approach, and I saw how it can actually be incorporated for the outside of the city. But since there was so many dense areas in the center, that was the reason of my doubt to implement. But as you point out, there is quite a large area for the main network to be implemented from the houses, so that's also my doubt. So that's fine.
Well, that's what we used to. Well, once we lived in villages, all this energy, even their food, came from the surrounding. My grandmother told me, let's go to collect potatoes. And we walked by feet to the field of potatoes. It was 1 kilometer. And that was the place where the energy came from.
Okay. Thank you.
I think we have an additional comment or question from Min.
Yes, I just want to say that maybe we can look at the build site as a specific use case as well. So for a specific situation of the site within the city. So it's a solution for periphery locations where you have these advantageous conditions regarding your land. But I think that such interventions might be quite costly if you are doing that in the center of the city because of the dense infrastructure that is built underground. So I think that also it depends also on the situation. Each city, if this solution is applicable, but I think that in NeutralPath in Dresden we have set out a pathway that can be at least considered in other places to be replicated there.
Yeah, actually, thank you, Min, for raising this topic of replication. Actually, I would like to ask to the other participants if you have any question, but also any comments about the replicability of the solution and approaches that our speakers have presented in your cities. I guess that you come from different cities and contexts, so it would be nice to know if you have thought about which elements of this presentation could be replicated in your cities and in your context at district level. Let's hear. from our audience?
Just one remark to this. Of course, we need to speed up with change, but on the other hand, this is research project and we do something new, and we need also some phase of monitoring. So, and we need to prove how it works. Before that, I would not say let's replicate and speed up. I think we should speed up the process of building it and testing it. This is important, and this depends on money, and well, the money needs to be secured to realize it, and this is, from my point, the most important point for now.
We need another webinar for business models and financing, indeed. Arnold, the word to you.
Well, I can comment a little bit in relation to the city of Ghent. So we're also partner in NEUTRALPATH. Ghent is one of the fellow cities. I don't believe someone of the city of Ghent is actually present. I'm from the University of Ghent. But in Belgium, we face a problem that we don't have a tradition of district heating networks. And so we also don't have energy companies who can take up the lead of developing new networks. So that's a big barrier. So the city of Ghent, in their philosophy of transitioning towards renewable energy, they're mainly looking towards electrification. So heat pumps, but decentralized at the level of each building or each dwelling. So that's one of the goals they're trying to achieve, and trying to create the conditions for owners to make a change. But on the other hand, we're also looking into some of the districts of Ghent to develop very local heating networks, but comparable to what you presented here, maybe even smaller scale, by using opportunities of existing developments where, for instance, boreholes and geothermal heat pumps will be installed, and by using this opportunity to expand this network to a slightly larger scale. So also serving not only the development that is planned at a certain spot of land, but also to serve neighbors within the same district. So these are things we are looking into, and in that sense, the solutions like the soccer field storage, soil storage, might also be interesting for our city. But taking into consideration that we have a lot of different barriers. Also, a barrier in Belgium is that most of the dwellings are privately owned, so that also makes it difficult to go to collective solutions.
Yeah, thank you, Arnold. Well, that's clear that we have barriers in Dresden as well. Barriers are enough and everywhere. But we need to fight. Yeah? And one idea I would like to follow, and we can maybe continue the personal contact, we have it anyway, was the idea that we can use borehole fields. So I did also some simulation on borehole fields. The advantage of this is the regeneration by the climate is limited to the depth of 10 meters about. Yeah? And below 10 meters, you have a storage volume. In Germany, we are allowed to drill boreholes up to 100 meters. So without with a normal case of application. So then we got 90 meters of storage volume, which could be used as a seasonal storage. And if we activate this as a seasonal storage, we could even, that could be interesting for Sachsen Energy, also upload the heating energy in summertime, which is too much, in a borehole field to regenerate it and reuse it in wintertime, because we got the real seasonal effect. And the energy loss is quite little compared to an energy storage which is next to the surface. If we work in the first 10 meters, then of course the regeneration of the climate has a big impact, and storing of energy just makes sense in case of phase change energy. Yeah? If we go via ice phase, this makes sense. But underneath this 10 meters, we can just use sensible energy, store it for a while, maybe for half a year, and use it later on. And without regeneration, you got difficulties anyway, because if you just take the energy from the ground and with no regeneration from the surface, from the climate, then you will create a sea of cold in the underground, yeah, and this will grow and grow, and this will lower the efficiency of your heat pumps, and this is not a sustainable solution in my view. And therefore, regeneration, sustainable operation of a borehole field should be that we regenerate with the same amount we get in wintertime out of the field. So the heating and cooling amount should be the same.
One more comment towards Ghent. We have a nice situation here that Sachsen Energie is, of course, partner as the local energy supplier, but like the goal for us is develop actually business models who are attractive, like who are economically attractive. So it doesn't need to be like the local energy supplier, but also like companies hop on the train to say, okay, this can actually work. So you find investors actually to build these kind of networks, such as contractors, because contractors are not only like local supply companies, but also just regular companies on the market who supply people with energy for good conditions.
Okay, we can discuss next month in Dresden.
Yeah, I'm looking forward.
Maybe just one final comment from some participants that are not part of NeutralPath, just to hear also from other perspectives and other projects. Julia has already participated, but someone else maybe who is not part of NeutralPath, so we can also hear from other experiences. Anton, maybe I see you, your camera is switched on. I don't know if you would like to share any comments from your side as well. I think you are not a project partner of the project. Well, I think that then we don't have any other comments or questions. So we can wrap up here. I want to thank you very much, Katja and John, for your presentation. Thank you. And thank you all for joining us today. I hope that you enjoyed the webinar and the discussion. I think that we have raised very important points also for the future, as for example, the business models that needs to be explored. So if you enjoyed the webinar, join the community so we can also organize other webinars, and you have also the access to the contacts and to this network of other professionals and peers at European level that are working on positive energy district and overall on the energy transition. So we can all focus our efforts on make it happen. Thank you all. Thank you very much. And to the next webinar. I left in the chat the link to join. Thank you.
Thank you, Stefania, for a very good work and moderation, and giving us the opportunity to present our technical things here in this surrounding, in this environment.
Of course. Thank you so much. To the next one. Thank you all. Bye.
Goodbye.
Bye-bye.
Thank you. Bye-bye.
Bye.
Bye-bye.